Hi there, my name is Jeff DuBose and I'm a graduate student at the University of Notre Dame, and today we'll be talking briefly about solar water splitting, making fuel from water and sunlight. So what is solar water splitting? Essentially what we're going to do is we're going to take sunlight and we're going to use that to break up water molecules, or H2O, into hydrogen gas, which is H2, and also oxygen gas, O2. So we're going to take just simple water and we're going to produce from this liquid water two different gases. One of them is a fuel source, which is the hydrogen, and the other is a byproduct, which is just oxygen. So how does solar water splitting actually work? Essentially what we have is we have the sun here shining light down onto our solar cell, which gets absorbed by the solar cell, and that produces what we call a voltage, or in other words, that pushes electrons through the solar cell and then into this electrode, which is dipped into our water bath. So as electrons are accumulating here, we have H+, or hydrogen ions in solution, that will combine with the electrons and that'll make hydrogen gas. And that can be our fuel source that we can collect later on and then burn to produce energy. So that happens at this electrode. At this electrode we have electrons moving away, and that means that H2O, our water molecules, will eventually form O2 as one of the byproducts. So overall what we're using is we're using the sunlight from the sun in addition to with a solar cell which pushes electrons around. And then those electrons will make hydrogen gas and also oxygen gas as the byproducts. So this is a very clean way of making energy, because once we actually collect the hydrogen gas and burn it to make energy, the only byproduct is just water. Next, we'll demonstrate how solar water splitting works through a quick demonstration. If you want to do this at home, you need a few things. You need a jar or container, a lid with two holes drilled into it. You'll need water, of course, your electrolyte, which will make the solution nice and conductive, something like sodium sulfate, a spatula or stirrer, two graphite pencils, which will act as electrodes, and then also a small solar panel that has alligator clips. We will be using a silicon solar cell to first convert light into electrical energy, and that energy will be used to split water and produce hydrogen gas, our fuel, and oxygen, a harmless byproduct. The setup includes two pencils, which will act as electrodes, along with a jar and a cap, then sodium sulfate, which acts as our electrolyte, a spatula to stir the sodium sulfate, water, and of course, our photovoltaic solar cell. First, you will carefully pour the sodium sulfate electrolyte into the container. After that, you'll take the water and pour it into the container as well. Next, stir the electrolyte until it is completely dissolved. You may have to stir for a while. Next, add the cap to the jar and slide the pencils in through the two holes on top of the jar. Once in place, take the alligator clips that are connected to the solar cell and connect each one to one of the pencils. Make sure that the metal clips of the alligator clamp are fully touching the graphite portion of the pencil. Now observe as each pencil produces small bubbles. This is the result of water splitting. At one pencil electrode there is hydrogen gas being produced. This is the fuel gas that could be used, for example, to drive a hydrogen-powered car. At the other pencil we are producing oxygen as the byproduct.